everyone, welcome. Thank you for coming along. So this is the public holiday recording of the lab, so that if you haven't, if the Monday, because of the public holidays, it's not possible to, and the compression of this semester, it's not possible for us to do anything about this public holiday on the Monday the 3rd. So the lecture's online, I've already done that, the tutorial's already done, and the computers, these two computers, Comp6 and Comp3, would be today's lab. So I'm going to do that here. I'll post a message in those so that that can be understood. We'll be back on Wednesday, which is the 5th, and we'll be doing our work normally there. So all that's required is to go into Mathematical Modelling for Summer, go to Modules. Hopefully you've already had a look at all of that. There's no point really going to the labs because it's Monday's lab is not going to happen, either of those two labs, because it's public holiday. So that's kind of put that on. But when you go down to the labs module, what you'll find here are the questions, the tools. One's a notebook and one's a PDF. So you just open those and download them, and then we're ready to make a start. So that's what we intend to do now. So I'll just open those up. So I've got the questions for Lab 1 questions. I've got the tools file, which has essentially got what we do here with this. And then there's another one called Getting Used to Jupyter. And they're all in the reference section as I showed earlier. So questions 1, tools and tools. And then if you go to resources, there's this Getting Used to Jupyter instructions file. There's a few others there, of course, but you can download this one as well. Okay, so there's a little bit of rigmarole to get yourself set up. Once you get into that space, though, it's fairly straightforward. So questions Lab 1 said investigate 2 different data sets in R via Jupyter, or however you want to do it. You can use Anaconda, and then go ahead and have a look at this. Now, an important note that I've made here is that I'm just going to use a highlighter, I think. While I won't be asking questions about producing R output in exams, so I won't be asking questions, I will be expecting you to be able to interpret output from R. Okay, so there'll be tables given in R. You won't be programming in the final exam. You'll be just looking at this and going, okay, let's put this. What does this mean and how does that work? Okay, so let's just keep that in mind. All right, that's enough of me there. All right, the next part is let's have a look at this getting used to Jupyter thing. So R can be used on notebooks, and the notebooks are able to be opened. And one of the ones that I've got there is R instead of Minitab. So once you've downloaded it into your system, what you would do is you would go ahead and you would have a look for your file that you've downloaded, wherever that is. Okay, so in this case here, I'll just bring this across here, and you'll be looking for your particular files. So if I go to documents, and then if I look for downloads, I think R instead of Minitab is the one we want. And the R instead of Minitab is just a basic introduction. Okay, so R, you need to identify where it is in the first instance. Okay. So and so there, under your resources, okay, under your tutorial, so there's a couple of files to open. Okay, it's a few files to open. That's the one we want, isn't it? So there's your R instead of, so they're in the labs. They're in the labs there. Beginning Jupyter instructions and R instead of Minitab. If you download that file, then you can pull it up into your section. And when you open it, this is what it looks like. Okay, so there's two ways to do it. Now at the moment, I'm looking through Anaconda. So that's the notebooks on my local desktop. But having said that, what we can do is go to Jupyter. And the one that we want is Try. So Jupyter Try. Now you can use the classic notebook if this one stalls a little bit, but the Try Jupyter Lab is the one we want. So we'll go into that, and it takes a little while, and basically what it does, it brings up the same thing as Anaconda. So it doesn't matter which one I use here for this, you'll be doing the same thing in either system. Okay, so it doesn't matter which one you use, you'll be doing the same thing in either system. Okay, so it doesn't matter if it's Jupyter Lab or if you've come and seen me and gotten yourself organized. Okay, so the first part was get your R instead of Minitab. Okay, so we need to upload that, and there's the upload file. So this is if you're doing it there. So R instead of Minitab, I've got that in my downloads. So I'm opening that, it's pulling it up, there it is, and I've loaded that in just by double clicking on it. Now if I click on the folder, it'll collapse that menu. Okay, so we're here having a look at a few basic ideas. Now the idea here would be that you would work through this just on your own accord. Okay, so you just type in some things, use it like a calculator, just to familiarize yourself with R, getting used to R and seeing how it works. Okay, and then it's asking for some more. They're different computations now, so you would go ahead and type in just those, 256 plus 588. Okay, and then you would press Shift Enter, and it'll give you the answer that you want. Now it's not easy to pick them up that way. You can try that if you want to in pasting, but for some of the symbols they won't work. So for example 24 by 19, that won't pick that up. So I'll put that in there. It doesn't know how to interpret that times, and so it has an error. So I have to get that symbol and put a times in off the keyboard and then try it again. Shift Enter, and it's okay. Similarly for division, it won't work. So you just got to be careful what you expect the machine to do. Okay, so it's just a little practice, just getting you used to a few ideas. And Shift Enter each time, and 4 raised to the power 7 just each time, and it's showing you how that works. Okay, so very straightforward in terms of use. Have a little practice, change a few numbers, see what you think. Nothing too high stakes. Yes, if you sent me this, that would be good enough for your assessment 4. I'm keeping that assessment 4 very low stakes, aren't I? Very low stakes. Okay, so if you have a class, a type of data, I'll just quickly run through this type of data. It'll show you about 10. 10's a number, you say. Okay, well, what about 10? Well, I want R to tell me about 10. It's numeric. Okay, so I want R to tell me about whether or not Boolean. Okay, so what we can do is we can do the class of true. So if I just grab that and pop that down here, and then just grab true. I don't want the period there, just that bit will do, please. And change that for that, and do Shift Enter. It's telling me that it's logical. Okay, if I repeat that for 10, it'll go ahead. And if I grab the 10 just like that, and I put this in, it'll say, wait a minute, what are you doing? That's not 10. I don't know what that is. So what it's saying there is it wants the double quotes. So all you do is just pop the double quotes in, and away you go. It's a character. Okay. Assigning variables. So it's just a very lightweight thing for you to work through. X is assigned the value 10. You can use equal. Okay, so if I do that now, shift enter, it didn't do anything. Well, yes, it did. It put 10 into X. Show me. There you go. 10's got X in it. What about this one? You're not using the left arrow. No, I'm using the equal sign. It does the same thing, but for Y. Put 15 into Y and show me what Y looks like, please. Oh, thank you. Okay. So it wants to assign Z. So we can have Z equal to, what have we got? Hello world. Let's just grab that there, control copy, and pop it in there, and we'll print Z. Hello world. Okay, and you can do some basic maths with it. We assign A 5 this time, B 8. Let's assign a variable, the sum of those two, and print the variable. That's right. Okay, so now I'll get you to go through and assign 12 to C and 6 to D. Multiply them together this time and print them out. So you basically will repeat everything here, but instead of having A plus B, you might have A times B. Okay, so in this case it might be the variable C underscore times underscore D. That's the variable. Is going to be loaded up with C times D. Now, because I haven't done anything with C and D, it doesn't know what to do with C and D. So if I hit that now, it'll go, excuse me, I don't know what you're talking about. So you need to put a C statement in and a D statement, and then print. You'll need to print it, won't you? So we grab that and pop it down here. Control copy. Now that will show me what C times D is. So I encourage you to have a look at that. Okay, now that's the simple stuff for using R. I really want you to work through those examples yourselves. Just spend a bit of time having fun. I'm not, apart from you handing me some work by email, just your PDF. I don't want the notebook file. I can work out what's happened from the PDF. That would be enough. Okay. Alright, so very quickly some vectors. There's some things in here I'm not going to get into a bit further on. We can have a look at vectors and matrices. The data frame section is very interesting to have a look at, but there's some exercises for you to have a go at. I don't want those exercises. You don't need to give them to me. They're for you to have a look at. And certainly from section 2 on, it's completely optional, and in fact I'm not going through it. Okay, so I won't be going through section 2 for this time around, because we've got our own lab to get on with. Okay, so in terms of just quickly going through vectors and matrices, what's the effect here? Oh, we're putting a list in. So the variable is receiving a list. There it is. And it's getting all of those values. This one's getting a character list and those values. This one's getting a logical list. Okay, so you can create another vector with trains, cars, buses and ferries. So that would be a copy of this guy up here. Okay, and it would be called myCharVec, and print that out and see how you go with that. Okay, referencing the first element of these particular sections, or the second element, just by putting the number, the ordinal in, address in square brackets. So it's fairly straightforward, and look, it says to get the value. Okay. Alright, with our matrices it's a similar thing. Just the nomenclature tells you what to do with a matrix. Okay, 1 to 25, number of rows is 5 by row. So it'll go through one row with 5 elements, 2 rows, 3, 4, and 25. So it's fairly straightforward. So in this case here, if we want to go 1 up to 16, 4 by, it's essentially going to be the same thing, isn't it? So we'll grab that, okay, and we'll call that control copy, and pop that down here, and this one I want this to be my matrix. Control copy, so my matrix, and I don't want it to be 25, I want it to be 16. Of course that's what it was being asked to do, so by 4, and my matrix. Okay, and I think all we're doing there is 4. And there's my 4 by. Okay, fairly straightforward. So I'll let you have a look at those matrices. Nothing too heavy, please, nothing too upsetting, just nice and easy. Okay, an exciting one is data frames. You might have noticed some of the printouts in the lectures and in other plates. Well, data frames is how that's done. So what it does here is that you get a list and you print them out, but you might want to organise these. Instead of just being lists, you might want to have a table. And so the data frame call allows you to take each of those and assign them into a spreadsheet style presentation. So we've got the numVec and then each of the number of the elements. So they're just ordinals of how many there are, and then for each array. So at address 1 in numVec there's 5, at address 4 there's 32, at address 2 in charVec there's oranges, and so it's just showing you the contents of each of those. So it's quite an interesting way forward, and I encourage you to have a look at that. Okay, what happened there? So I'm just going to grab that. So my data frame. So what's that? Let's just have a look at that. There you go. Must have had the wrong thing printed there. So if you get an error, just go back and try and get the nomenclature right. It's fairly straightforward. So putting my DF in together showed me what it looks like in that form. We call that a data frame. It's a bit like a spreadsheet. And so we've got contents, third contents. And what we're doing is effectively truncating it, isn't it? We're getting particular sets, okay? So we want 1, but we only want to go down 3. Okay, so we want 1 numVec and charVec, and we only want to go to a depth of 2. So we want to go down 3 in each of the columns, 1, 2, 3, but we only want to go for a depth of 2, which means we're only going across numVec and char. Okay, so how you do that, how you address that, I'll let you have a look at the last 2 rows in the first and third column. Okay, seeing how you would think about this addressing mechanism for MyDF. Okay, there's a clue there. It's a bit of a giveaway, isn't it? Okay, so what I'm going to let you do is just have a look through that, and by all means, that's a lot of fun at this point. But I don't want to get too far ahead because it's just our first lab, and you'll be able to come back and have a look at this data analysis later on. All of the resources that you need are in the section that I showed you earlier. Okay, so once you've had a little play with that, then what we can do is we can go back to, after we've had a look at our instead of Minitab file, and that one just tells you a little bit about how to use the notebook and the interface that you use. So it's pretty straightforward. If you get stuck, it's got some clues there. Alright, so let's have a look at question 1 for our lab 1. Alright, we've got 2 questions that we're looking at, and we're having a look at these particular data sets and how we're going to manage them. Okay, so if I go over here, I'm just going to do a new one. I'll just go up and summer, and I'll just do a new one, a new R. So that's in that particular directory there, and it'll be saved as untitled. There it is, until I change that. Okay, so what we want to do is we want to have a look at. I'm going to just bring that one over so it's out of the way. Look at our questions. Alright, so there's 3 methods of measuring a quantity, and the methods themselves are just hypothetical methods. This is the data from each of the methods. Now the true measurement's 80, so you don't normally, well, you would know that in a practical sense. In a way, that's a bit like the population element. So we're getting the parameter at a true measurement of 80 out of the population. Normally what we do is take samples and try and work out what that true measurement is. But in this case it's given to us. Okay, so it's given to us as a true measure of 80. Okay, so in effect that's our population mean. So we'll say mu is given. So we're interested in the accuracy and precision. Now there's a couple of words for you. What is the accuracy and the precision? Okay, so we've got our method 1 and its data set, method 2 and its data set, method 3 and its data set. Okay, now it's easy enough to put these things in, so I'm going to use that tools PDF, and I'm literally just grabbing it like that. Control copy, drop it in the cell, Control V, and press enter. Okay. That's all right. Now for question 1, we want to know how to get these values in, and we do the same thing. We make up some variable, we populate that variable with the data that we've been given. You can do it by hand, or you can use my tools PDF to populate it. So if I drop it over here, so data method, that's just a variable, so that's this method 1 here. Okay, concatenate that with all of these values, and literally I just grab them and cut and paste them into that list. Okay, so I'm storing the data for that set. So all this is going to do is load each of those values in there. That's all it's going to do. Okay, so if I press Shift Enter on that, it's just going to load the variables in. And that's complaining because of the fact that that's been left, and it thinks it's not a comment, so that'll fix that. Alright, so it's put the 3 methods in. Well, if it's put the 3 methods in, the method data, I'd like to have a look at that. So all I've got to do is put each of the data on the line and call it, and it'll show me that I have indeed put those values in. Okay, so that's all I'm doing, plotting those out. Now that doesn't help you much on one level. If I were to take the comet plot and have a look at it, we know that this is not going to show us anything. Okay, but if I grab data method 1 and have a look at the plot of data method 1, we know this is the puzzle of statistics. It's not going to show us much meaningful other than a whole bunch of dots scattered around. Okay, so we need to do our statistical intelligence to make headway, and we know a better way of doing that is to do a box plot. So a box plot of that particular method, and that's more informative. So it shows us the middle score, it shows us the middle 50%, and it's showing us that there's a fair amount of skewing. Okay, it's skewing down one end, so it's a big, large positive skew data set. Okay, so what we want to do here is look at these side by side, because we're comparing them with a mind to understanding accuracy and precision. So if we're understanding accuracy and precision, what we're looking to do is just have a look at these and think about them in terms of their groupings, one with respect to the other. And of course the simplest way to do that, I think, is to simply have a look at them side by side. So we put a comma and we put in there data method 2, comma, data method 3. There you go. So what we're able to do is have the box plots side by side. So looking at a visual indicator like this will help us understand what's happening with our values. Okay, so in terms of accuracy and precision, okay, discuss the apparent effectiveness of the three different methods in terms of the concepts of accuracy and precision. So we see that the true measurement is 80. So which one of these has 80 in it? Well, method 1, the score of 80, that is, the data point is inside this set. Whoops, 80 is not in method 2 at all. So that's not very accurate, okay? But 80 is also in method 3. So in terms of accuracy, method 2 is not so accurate. Okay, so in terms of method 1, method 2, and method 3, we can say that not accurate, because 80 is simply not in the box plot. It's not even in the data set. Okay. Method 1 is very long. It goes from 84 to 78, which is what, 6, but this one here is like 79 to 83. So the interquartile range is much smaller. 79 to 83 is only 4. So the method 1 is 6 in length, method 3 is 4 in length. Okay, so in terms of middle 50%, or IQR, I would prefer to express that. Okay, we've got one that's 6 and one that's 4. So at the moment, in terms of accuracy, it looks like the most accurate would be 3. Okay, so that would be the most accurate. This is somewhat accurate, so most accurate, somewhat accurate. That variation is showing up, okay, and it's showing us by the width of the interquartile range from top to bottom on these. Now, of course, the next thing is, what about the precision? Well, precision is directly related to variance. So method 2 has the smallest variance, that is the smallest IQR. So its variance is low. Even though it's not accurate, most of the values are within a small range, so we can consider that to be precise. What we really want is precision and accuracy. We can't use M2 because it's not accurate, but M1 has both. It's got a broader IQR, so we can say it's somewhat precise, but it's not really precise like 2 was. And for this one here, it's not the most precise, but it's in the middle of the 3, so it's got that middle precision. Okay, middle precision. So the one that we would use is the one that is probably M3. I think M3 would be the one that we would want to use because it's the most accurate, and its precision is very good as well. So again, in characterizing the data, we're really saying, okay, we're not going to make big statements about everything. We're just going to observe what we observe, and that will be what we have. Okay. So that's all we've done. We've just put the data in, we've had a look at it in terms of accuracy and precision, and we've used our measures of central tendency and our measures of variance to give some indicator of accuracy and precision. Although they're not really things that we want to spend a lot of time on, because we're more interested in variance and explaining variance, but this is one way to explain variance. It's one way to explain interquartile range. Alright, the next thing we want to do is obtain summary statistics. So I'm just going to copy all of that because it's already populated, and go to the new line here, and I'm going to change box plot to summary. Now, I don't think this will work actually, so I might have gotten a bit ahead of myself. So it's only giving it to me for the first one, so I'm going to do it in a list. And I'll take the other datas out. How's that? This one. There you go. So that'll give me the summary for each of them. Okay. So we don't need to do all of the separate parts. We can see the median. We can see any skewing by comparing that with the means. Okay. So the means and the medians are very close. Remembering that this one doesn't have 80 in it, so it's not accurate at all. But this one here is the one that we said was probably going to be the best one for us to consider this method idea. Okay, so in practice, that's the kind of thing that we would be looking at. We've got the least amount of skew there, I think. We're very close. The quartile range is pretty much as I explained it to you, within 4 and 6. So all of those supporting ideas help that. Okay, so very straightforward on that level. Okay, so all right, that's good. All right, the next part we want to have a look at is the question for question 2. Now notice with the question 1, there were some parts to it. Characterize your data, characterize your data, characterize your data. We're doing a comparison of measures of central tendency, measures of variance for different methods. 3 data sets, characterize them and compare them and just make statements about them. Okay, not over the top conclusions, but just what the data points to. Let the data speak. It's not your job to overspeak on behalf of what's going on there. It's not a problem to solve in the same way. I know the engineers will cringe and say, oh, we get those explaining things happening. That's not what's needed here. What we need here is just let the data speak, assist it as much as you can, okay, in terms of visuals and in data, but we don't want to overstep and draw conclusions at this point. We just want to characterize the data and just highlight certain features, and that's all that's really needed, much as we did in the tutorial, if you've had a chance to have a look at the tutorial. Okay, so a serious impurity in recycled PET plastic is aluminium, which can clog filters of extruders when recycled material is used. The following are the amounts in parts per million by weight of aluminium found in bi-hourly samples. So that's twice an hour. Hopefully that's understood what that means over a 2-day period. Reading left to right. Now again, you can just do that manually if you wanted to, but I have grabbed that in your tools folder and you can just copy it. No. You can just copy it over, and what's happened there? Just got to copy it over. There you go. And so that's the data from the list, and it's been dropped in to PET data. And it's complaining because that's going around the line, I think, as is that one. Okay, so that 140, just those little pick up things, just to pick them up. Don't panic if you get the warning message. There you go. So what we've been able to do is put that data out, and it's the same. You can double check it, then you can go through and double check it. Now it's in our system, what we can do is we can have a look at our data and try and understand what's happening with the aluminium filters, the aluminium that comes in. So using the plot library, now I've done this for you, so we're looking for trends. So we're going to run a chart that will show us the trends or cycles in the data, okay? And we do that simply by doing plot function, So we're going to plot the data pet. We're giving YLab values, type. There's a number of different types. And when you have a look at R instead of Minitab, you can go to this intro document and you can find those kinds of things like types. Okay, that's at the very top of that document. Okay, I will close that one. So that's that one. You can have a look at that. So the type, and there's different types, there's heaps of them. Okay, so what we do is we populate that and we go ahead. Now that will complain because that's a comment, and change access label. So now that won't complain, and when I do shift enter, it's giving me a lovely time series of what's happening. Okay. So what's happening with our trend values on this plot? What's happening with it? Okay, so what we know is that when we start using the values that have been entered, okay, these are the parts per million in weight of aluminium found in samples. So the parts per million, so 300 parts per million, and then it's dropping, and then it fluctuates. Okay, it fluctuates each one of these by hourly across the bottom. We can suspect that that's 2 days, so 24 hours of production time. So we can see that they're fluctuating. So each one of these parts per million has something to say about our filtering process. Generally the trend is fairly constant until we get to this 20 index, and all of a sudden it shoots up. So what can be said about the shooting up part for the index 20? We've spiked up at 500 parts per million by weight of aluminium, and so that means that our filters are blocked, isn't it? And they need to be cycle clean, which is a very common thing for dust particulates and extruders, which are getting clogged by the things that they're trying to filter, and so they have to be cleared. Now that can be done automatically or it can be done manually. So that means people have actually got to physically go and rotate the system through a new set of filters and clean the old ones, or there might be a thumper that thumps mechanically hits the filter bags or the filter membranes and clears them, or they could be backflushed, any number of things, as happens in a pool filter. So the time series gives us a very interesting interpretation and helps us to identify at what points in time there's clogging and what to do about that. Now we can take a histogram as well, and we can have a look at the histogram and see what the data's like in terms of distribution. So remember, a time series is one thing. It'll show us what's happening moment to moment, and if there's any trends. Is there a decreasing trend? Is there a leveling out trend? Is there an outlier? But a histogram talks about values that repeat, and so it gives us a distribution, a visual on the distribution. So we'll have a look at that and see what that is in terms of its spread and skewness. So again, in the tools file, I've grabbed that for you. So you just pop that in and just check that everything's going to be okay there, because I don't want it complaining. And so what we've done is nominated a colour, and we can see that as a distribution there is skewing because of this clogging value at index 20. So that's the normal distribution that's been skewed by that data point, and there are some common frequencies that are taking place once you put them into buckets. Okay, so that's about what we expected. The skewing's been caused by this outlier, and for whatever reason there was an increase in parts per million, and we understand that usually means a batch of material got in there that was contaminated. Alright, so the next thing we want to have a look at is descriptive summaries. So all we'll do is we'll do a summary of the data pet. So again, we can go to the PDF and drop it in, and that will give us summary statistics. That'll tell us the middle score. The mean has been pulled quite a long way from the median score or the typical score, and so we understand that the mean is being impacted by this outlier. This max outlier that's way up there is pulling the mean well away from the typical or median score, and so the median is giving us a good indicator of what the value is for that data set. Now, what are the median first and third quartiles? You can see that they're quite there, so it's very easy to see that from that point. We could also do a box plot, couldn't we? We could do a box plot. I'll let you do that. Now, D is interesting. It says, describe the shortcomings of the visual and statistical character of the data. Is there anything that can be done to improve the analysis? And you might say, well, what can you do? One of the things that we're learning in statistics is that we're understanding that density functions, probability density functions and the like are characterized by functions. That means that we can do things functions of functions. So in actual fact, what we can do here is we can take logs of all of these values and see how that would affect our data set. Okay? And whether or not we can think about the data through the lens of having the function that is the distribution function for this data set parsed through a log function. And in actual fact, that may well be a helpful thing to do to help us understand what the mean and the median are, because they're the things that we're looking for. We're looking for these telltale signs to help us. Now, it's a little bit early in the course for us to go ahead and do that, but just be aware that there are post activities that you can do once you've done your data and your summaries to try and tweak that. And if you decide to do Introduction to Statistics as, regression analysis as an elective, that's definitely a step that you'll be doing in that work. Okay. All right, oh, well, there you go. We've gotten to the end of it. That's tremendous. Okay, so there's nothing to hand in. It's just for you to have a go at. You can hand this in if you want to as part of your development in Assessment 4. I'm more than happy for you to do that if that's what you would like to do. Okay, you can use the labs if you want to demonstrate to me that hey Jason, I did this. How cool am I? That's all I'm after. Okay, if you wanted to use this particular example, I'm happy for that. Some of you already sent them in based on other things, and that's okay too. All right, that's tremendous as well. But if you want to use these labs as doing that, I'm not going to give you marks back because essentially I just want to see that you've made an attempt and that the attempt is sound, so it's almost pass-fail, even though it's worth 15%. So it's worth doing if that's what you want to do. All right, so okay, so that's it, guys. I'm going to give you back my head now because there I am, been talking with you about this, and so hopefully you've gotten some confidence in how to use R and all of the mysteries that can be exposed by using the various techniques within R, along with what happens in the lectures. And so that's enough for you to be encouraged and go ahead and do that. All right, so the final thing I want to do there is just to go back to that something that I said earlier, and that's this one here, isn't it? Because if we look down here and we look at the task, it simply says from the labs or questions from DeVore or something else, and all I want you to do is email them to me and show me that you've been able to put it together. I can print that out as a PDF and I can send that to myself. Okay, so I could send that to myself saved as a PDF. That would work as well, and I'd be quite happy with that. Alright guys, that's all I wanted. Thanks very much. I do apologise that we weren't able to get our first lab done together on the Monday morning, but it's a public holiday and I'm not allowed to expect you to do work on a public holiday. So I'm posting all this stuff Sunday night so that you can have a look at it if you choose to, but then the real work begins on Tuesday, I guess. So that means I will see you on Wednesday. Okay, I'll see you then. Thanks everybody.